Okay, let's dive into this. Welcome to today's explainer. If you're an 8th grade student tuning in, or honestly, just someone fascinated by the hidden codes of the universe, you are in the exact right place. Today, we're going to talk about finding hidden mathematical patterns. Because math isn't just some random jumble of numbers scattered on a page. No way. It is a deeply purposeful, highly organized system that acts as the literal blueprint for everything around us. So today, we're going to unlock that blueprint by mastering 2 specific types of mathematical patterns. Here's a quick roadmap of our journey today. We're going to cover 1. The beauty of order, 2. Decoding math sequences, 3. Arithmetic versus geometric, 4. Test your knowledge, and finally, 5. True education and morality. Let's get right to it. Section 1. The beauty of order, design in the universe. Before we even look at a single number, we really need to understand the philosophy behind what we're doing, because math is the language of structure, and this brilliantly illustrates the foundational idea here. Let all things be done decently and in order. Just as God loves order, math loves order too. Sequences show us how things can grow in a purposeful, predictable pattern. When you understand the pattern, you aren't just guessing anymore, right? You're predicting exactly what comes next because you understand the underlying rule of the design. Moving on to Section 2, decoding math sequences, finding the pattern. Now, let's roll up our sleeves and transition into the actual mathematical mechanics. As you learn this, I want you to kind of think of yourself as a detective. But before a detective can solve a case, they need to know the basic terminology. So let's clearly define our playing field. Our first word is sequence. A sequence is really simply an ordered list of numbers that follows a specific pattern. Our second word is term. A term is just the fancy word for each individual number sitting within that list. So in a sequence of numbers, each number takes its turn as a term. If you can remember these 2 simple words, you're absolutely ready to analyze the numbers. Now, you might be wondering, why do these sequences actually matter in the real world? Well, imagine a classroom where you add 2 new chairs every single week. That steady, predictable addition is a sequence. Now, contrast that with a viral video where your followers double every single day. 2 becomes 4, 4 becomes 8, 8 becomes 16. That explosive multiplication is also a sequence. Learning how to recognize whether things are just creeping up by the same amount or aggressively multiplying is completely foundational for algebra, for computer science, and absolutely for your financial literacy. It's a real game changer of a life skill. All right, Section 3, arithmetic versus geometric, decoding the change. Okay, this is the core of our lesson today. We know what a sequence is, but now we need to figure out exactly how it's growing. Let's put our 2 main suspects side by side. Over on the left, we have arithmetic sequences. These grow by adding or subtracting the exact same number each time. To test for this, you just take a term and subtract it from the one right after it. If that difference is always the same, boom, it's arithmetic. On the right side, we have geometric sequences. These grow by multiplying or dividing by the exact same number each time. To test for this one, you divide a term by the one right before it. If that ratio stays the same, you've got a geometric sequence on your hands. Let's walk through our first example step by step so you can see it in action. Look at this progression: 5, 8, 11, 14, 17. So what's happening here? Well, if we subtract 5 from 8, we get 3. If we subtract 8 from 11, we get 3. 14 minus 11? Yep, 3. Each number predictably builds by adding 3 each time. That number, 3, is what we call our common difference. Because the difference between every single term and the one right after it remains perfectly steady at positive 3, we can definitively say this is an arithmetic sequence. Let's switch gears and move to our second example to see how this one builds: 2, 4, 8, 16, 32. Let's test it. If we try subtracting, 4 minus 2 is 2, but 8 minus 4 is 4. The difference is changing, so scratch that. It's definitely not arithmetic. Let's try dividing. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. Look at that. We are seeing rapid multiplying growth happening between each progressive step. So the crucial point is that our multiplier here is exactly 2. We call this the common ratio. Remember, we find this constant ratio by dividing a term by the one right before it. Because it consistently multiplies by 2, this right here is a geometric sequence. But beware, detectives! Here is a major curveball. Look at this sequence: 3, 6, 11, 18. Let's run our tests. 6 minus 3 is 3, but 11 minus 6 is 5, so no common difference. It's not arithmetic. Okay, let's try dividing. 6 divided by 3 is 2, but 11 divided by 6 is certainly not 2, so no common ratio either. It's not geometric. Because there is no consistent difference and no consistent ratio, the answer here is simply neither. And this proves exactly why you must always, always check your math between every single term, and not just assume you know the pattern after seeing the first two numbers. Section 4. Test your knowledge, the rapid fire challenge. All right, let's turn up the energy a bit. I'm going to transform your homework into a rapid fire game show segment. You're the focused learner, you have the tools. Now let's see how fast your brain can spot the patterns. Feel free to shout out the answers as we go. Here we go, question 1. Identify if the sequence is arithmetic or geometric. 2, 4, 6, 8, 10. Look at the terms. Are we adding the same amount or multiplying by the same amount? Well, 2 to 4 is plus 2. 4 to 6 is plus 2. We're adding. That makes it an arithmetic sequence. Easy enough, right? Question 2. Identify the type. 100, 50, 25, 12.5. Notice how the numbers are rapidly shrinking? If we divide 50 by 100, we get 1/2, or 0.5. 25 divided by 50 is also 1/2. We are consistently dividing in half. That is a steady multiplier of 0.5, which makes this geometric. Question 3. What is the exact common difference in the sequence 9, 14, 19, 24? Okay, I'm telling you up front it's an arithmetic sequence, but I challenge you to calculate the exact difference. Subtract 9 from 14. Subtract 14 from 19. Yep, the common difference for this steadily growing list is exactly 5. Question 4. What is the common ratio in the sequence 3, 6, 12, 24? Find the specific multiplier powering this rapid growth. 6 divided by 3 is 2. 12 divided by 6 is 2. The common ratio is 2, making this a classic doubling geometric sequence. Final question. Is the sequence 7, 14, 21, 30 arithmetic, geometric, or neither? Let's check it. 7 to 14 is plus 7. 14 to 21 is plus 7. Looking a lot like arithmetic so far. But wait. 21 to 30 is plus 9. The pattern breaks. Did you catch that trick? Because the pattern isn't consistent all the way to the end, the answer is neither. Always check every single term, guys. Section 5. True Education and Morality, the Big Picture. Well, we've done the math, and you did incredibly well. But as we wrap up, I really want to step back from the formulas for a second and zoom back out to the philosophical why behind learning all of this in the first place. You see, the Academy Godly Learners series intertwines biblical morality with education for a very specific reason. Education without morality will hurt. Think about it for a minute. What is the point of being incredibly smart, of being highly educated, and knowing all the complex mathematical sequences in the world, if you just continue to make bad choices that end up hurting yourself and the people around you? True intelligence is pairing that sharp mathematical mind with a really strong moral compass. Romans 8, 6 through 7 promises peace of mind to everyone who keeps their mind spiritual. When an orderly, highly educated mind is paired with a deeply spiritual and moral foundation, the result is profound peace. And this is exactly what we see time and time again when people deeply engage with true, well-rounded education. So, I leave you with this final thought to carry with you long after this explainer ends. How will you use your orderly mind, your newfound ability to recognize patterns, and your overall education to make choices that heal rather than hurt? Mathematics gives you the tools to understand the world's patterns for sure, but morality gives you the wisdom to create beautiful patterns in your own life. Keep exploring, keep learning, and I'll catch you in the next explainer.